Hello, everyone. This is Shakil, and today I'm here to take a test of you from AQA Physics 9630, and the topic is limitations of physical quantities. Okay, so I'll be adding up this test in the description. The link, the Google Drive link will be there, so you can download that test from there. And then, of course, you'll have to attempt this test. Let me just take you through the test. This is question number one. This is question number two. This is from uncertainty. And then this is question number three. You can stop the video and you can solve it. And then later you can look at my solution to compare and mark yourself. So this is question number four. And finally, this is question number five. So there are total 5 questions and it's worth 30 marks, and you're supposed to attempt this test in 45 minutes. Okay, so let's begin solving it. As I told you, I am Shakil Mahmood, so I'm going to start solving this test. And you are in AQA Physics AS level, and today is 7th of October 2024. Okay, so the topic is limitations of physical measurements, and then the topic inside it is graphs and uncertainties. Okay, so let's begin solving it. If you look at question number one is related to the absolute uncertainties. And we can see that a student uses a micrometer to measure the diameter of a wire at several places along its length. These are the measured values. So 1, 2, 3, 4, and 5. So it means that the micrometer is used 5 times to measure the diameter of that wire, and it ranges from 0.58 millimeter to 0.50. And what they're saying is that what is the diameter and how you quote the mean value of the wire. So, well, this is the easy question. First of all, the mean diameter is sum of diameters divided by number of readings. So we have to add all of them together, and then we have to divide the sum of these divided by the number of the readings. So how many readings are there? 5 readings are there. In order to get the uncertainty over there, uncertainty in the mean value, it's maximum of d minus minimum of d divided by 2. So this is the formula. So maximum is this one, which is 0.58, and minimum, is this one, which is 0.50. So you divide it with 2 to get your answer. So here you go, your answer is 0.04, and that is only one option over here. So that's why we choose option C. And of course, the average would be coming out to be 0.53. Moving on to the question number 2. Okay, so question number 2 is the diagram shows the apparatus shown in the experiment to illustrate Newton's second law of motion. A trolley of mass m is accelerated by the weight. So the mass is there, attached to the string, hung through the pulley, and then there is a trolley of mass m. This is the horizontal track placed on the bench. So of course, this mass will be going down, and this trolley will be moving towards your left. So they're saying that the trolley and mass m are released from the rest and traveled a measured distance of 0.750 meter. The uncertainty in the distance is 0.001 0.002 meter. That is the uncertainty. It means the first value that we have is the value of S and the uncertainty in it. So S is 0.750 and the uncertainty is 0.002 meter. So one thing that you already know, both have same units and same decimal places. Like the uncertainty and the mid value, same unit and same decimal places. And this uncertainty is always written in one significant figure. Moving on, they're saying that the time t for the trolley to travel distance as 5 times. They're averaging the time, and all the 5 values are mentioned over here. So as this is the repeated values, of course, they will ask you to find the mean value of the time and the uncertainty. So as you know that, we have the formula that the mean is equal to sum of readings divided by number of readings. And for the absolute uncertainty in mean, so in the repeated reading, the uncertainty is calculated by taking the maximum reading minus minimum reading divided by 2. So now you have to plug in the values to get your answer. So if we first find the uncertainty, from here we can say this is the max value, and for the min value, this is the min value. So 0.81 minus 0.77. So we can just plug in the values, 0.81 minus 0.77 over 2. So it means that the uncertainty will be plus minus 0.02. So we can write that over there with the unit of second. And now for the mean value, you have to add all of them. And after adding all of them, you will divide their sum with 5 because you have taken the readings 5 times. So let me do the calculation for you. So the magic happened and I've done the calculation. The sum of reading is 3195 divided by 5 is the number of reading. So you get a time of 0.79. So this is your mean and this is your absolute uncertainty in mean. The next thing is the acceleration of the trolley is given by this expression a equal to s over t square. They're saying that you have to find a and you have to find its percentage uncertainty. It means again you have to do two things. First, you will have to find the value of a. Okay, for a, you use the formula 2s over t square. So the value of s was given over there. When you go back, this is value of s, which is 0.750. So 2 into 0.750, and for the t, you have this mean value, which is 0.79 square. So you will quickly do the calculation to get the answer. And let me do this quickly for you. So it comes out to be 2.40. So 2.40, and this is your answer. And now about the percentage uncertainty in A, you can see that it's S and T square, and the power rule is also there. So we say it is percentage uncertainty in S plus 2 into percentage uncertainty in T. Okay, but as you know that the absolute uncertainties are given, so the formula would be delta S over S into 100% plus 2. Why 2? Because it's the power of the T. So there is the power rule applicable over there, that the power is multiplied by the error of that quantity. So 2 is being multiplied by the error of T. So what you do is you just now have to put the values. So delta S was 0.002, if I remember exactly. S was 0.750. And then delta T, you just have calculated over there, which is 0.02, and the T is 0.79, and you multiply it with 100%, and you have to do the calculation now. So let me do the calculation. I will try that. I should not commit any mistake, because the mistake at this stage would be terrible for you, maybe, or maybe for me. So if we look at the answer comes out to be 5.33%. So this is 5.33%. So we can write here 5.3%. Okay, moving forward to next question, which is the data analysis question. So capillary action can cause a liquid to rise up a hollow tube. Figure shows the water that has risen to the height h in the narrow glass tube because of the capillary action. Okay, so this is the water. This is height h to which the water is clinged through this glass tube. And they said that the graph of the height versus the angle for this particular tube is plotted. The values of height, which is in millimeter, and the the temperature in degrees Celsius, not angle, it was temperature, because like usually we use this for angle as well, and usually we use this for temperature as well. It all depends on the unit. So if it is like this, then it is angle, and if it is like this, then it is temperature. So this was temperature. So they have plotted all the values over there, and the error bars are also there. You can see that this one is the plotted value, and then inside that is the error bar. So this is the error bar. So this is error bar. Okay, so now what we have to do is, in this question, they have told us that uncertainty in measurement of H is shown by the error bars. Yes, uncertainties in the measurement of temperature are negligible. That's why there are no horizontal error bars. Okay, so they're saying that draw a best fit line for these data. Best fit line. Okay, how to draw the best fit line? Best fit line is a line that passes through points such a way that if the points are not coming on the line, then they should be equally distributed. So you have to draw jointless line. Jointless line. You have to draw a thin line. And then points not coming online should be equally distributed. So points not coming online should be equally distributed along line. So that is the best fit line. Well, how I can do that? Let me just try to draw the best fit line. Please pardon me, because I am just drawing it with a free hand. So this is, let's say, an imaginary best fit line. You have to use the ruler. And then the point should be equally spread along the line. So that would be the best fit. Okay. The next thing is, there is a suggested relationship between the quantities between which the graph is plotted. H naught, K are the constants, and they're saying find H naught. So whenever the graph is there, and after the graph, and the graph is again a straight line, and then an equation is given, then they ask you to find something, you always have to follow the same method. Then what? You know, the equation of straight line is y is equal to mx plus c. Y is the subject of the equation, because if we plot the graph like this, this would be the y-intercept, and then this would be the gradient of this. So you combine all of it in the form of the equation, which is y is equal to mx plus c. In the similar way, this equation is given, so you have to see what is along y-axis. It is h, so it should be subject of the equation. And the x-axis thing should be coming after equal sign. Coming after equal sign in the equation. So h, that's fine. But after equal is h naught, but it is theta that is plotted. So we shift it place over here along with the negative sign. So minus h naught k theta plus h naught. And now you have to make the comparison. So when you do the comparison, along y-axis is h, along x-axis is theta, that's perfect. So comparison gives you the value of the gradient as minus h naught k, and the comparison gives you the y-intercept as h naught. And as you have to tell the value of h naught, so of course you will be looking at y-intercept. So h naught is simply equal to y-intercept. So what you will do is you will just read, you will just continue your line from here until it matches the y-intercept. So you will read over there. So that will be your value of the y-intercept. So it will be around 165, but the range of answer will be there. But the range will be too short. Then they said, show that the value of h naught k is about this. So we say, okay, h naught k. What is h naught k? So we say, look, h naught k is over there. So we say, okay, that's quite simple. The gradient is minus h naught k. So find gradient. Find it, find the gradient. So let's move to the graph part now. And on the graph part, you will just label, let's say, this is your first point, and let's say this is your other, or you can just draw them like this. So just find the gradient. So this is having the coordinate of x2, y2, and this point is having coordinate of x1 and y1, and you can find the value of the gradient over there. So when you find the value of the gradient, so the gradient would be like y2 minus y1 over x2 minus x1. So as I have done the working, so the gradient is minus 0.89. So you just put its value over there, minus 0.89 equal minus h naught k. This minus minus goes away. So you will say that h naught k is almost equal to 0.9 millimeter per Kelvin. Why the unit is like that? Because gradient is y over x, so the unit of y is millimeter and the unit of x is Kelvin. That's why the unit of gradient is millimeter per Kelvin. Okay, then they said that determine the value of the k. It's quite simple. Again, you have to use this. As you know that h naught k is 0.89, so you will say k is 0.89 over h naught, and for h naught you had calculated it over there, which was 165. So 0.89 over 165 millimeter will give you the answer as 5.39 4 into 10 raised power minus 3. So it means that it is 5.4 into 10 raised power minus 3. And about the unit, this is millimeter per Kelvin, and this is millimeter. So millimeter, millimeter goes away. So your unit is millimeter Kelvin. Sorry, the unit is per Kelvin. Okay, moving on to question number 4. This question is about measuring the density of the rubber used to make a solid ball. So she made the diameter of the ball 5 times with the vernier calipers, and the figure shows her measurement. So the diameter for the 5 diameters are given over there. So now they're saying that the diagram shows the ball and the vernier calipers of one of the measurements as shown below. So this is the vernier calipers. So the vernier caliper reading method is main scale reading plus vernier scale reading multiplied by least count. So the main scale reading is this one. This is main scale reading. So you can just read it from the point just behind the zero over here. So this is the zero of the vernier scale. This is like between, this is vernier scale, this one. So behind the zero is this reading. So this reading is 3.9, right? And of course, this is centimeter. And so main scale reading is 3.9. And then the vernier scale reading is the line from these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to see that which line is exactly coinciding between main scale, this is main scale, and vernier scale. So if you look, this line is exactly coinciding. So just count its number 5, 6, 7. So this is line number 7. Write 7 here, and its least count is 0.01 centimeter. So what you do is you add them, 3.9 plus 0.07. So this is 3.97 centimeter. So that's how you read vernier calipers. So this is 3.97 centimeter. Remember, it's vernier caliper reading and micrometer screw gauge reading formula is same. Main scale reading plus vernier scale reading multiplied by least count. Okay, now they're saying calculate the absolute uncertainty in the mean value of t. Okay, so the absolute uncertainty in mean value of t is max d, because this is the repeated reading, minus minimum d whole divided by 2. So if you look over here, this one is the max reading and this one is the minimum reading. So it's 4.05 minus 3.91 over 2. Yeah. So this comes out to be 0.14 over 2. So this comes out to be 0.07. So the absolute uncertainty is 0.07. Now you have to find the percentage uncertainty in mean value of t. So you have to find percentage uncertainty in mean value of t. That is absolute uncertainty in mean value over mean value into 100. So we already know the absolute uncertainty in mean, which we just have calculated, but we still have to look for the value, the mean value, because this is not the mean value. The mean value is you add them, like here, the mean value is the sum of readings divided by number of the readings. So I quickly have to add these values without making a calculative error so that you can get the right answer. So the answer comes out to be 3.988. 3.988. So you can write 3.99. So it is 3.988. So if I do the calculations, so the final answer comes out to be 1.7553. So it is 1.76 you can write, or you can write 1.8% as well. Okay, moving on to next, the part the student measures the mass of the ball to be this. Remember, this is the mass of the ball and this is the absolute uncertainty and mass of the ball. So they're saying that you have to calculate the density in kilogram per meter cube. Okay, that's fair enough. So as the ball is the solid sphere, so its volume formula is 4 by 3 pi r cube. And as you have measured the diameter, so the radius is d by 2. And when you calculate that, it is d cubed by 8. And this 4 and this cancel away. So final formula is pi d cubed by 6. So this is the formula of volume in terms of diameter. Okay, so you have to find the density. So density is mass over volume. So we already know the mass, which is 48.7, but unfortunately, we don't know the volume. So for the volume, we use this formula as I told you over there. So the diameter, uh, the mean diameter was 3.988. So 3.988 cube over 6. So let me quickly do the working for you, as it is cube, so be careful with that. Okay, so it's cube divided by 6. So the answer for the volume comes out to be 33.21, and it was centimeter cube. So it means that you will be putting this value over there, 33.21, putting this value over there. And the final answer is 48.7 divided by your answer. So that is 1.466 gram per cm cube. This is your answer. But the problem is they're asking in kilogram per meter cube. So we know that 1 gram per meter cube. Oh no, I'm making mistakes. Never mind. 1 gram per cm cube is equal to 1000 kilogram per meter cube. So what you do is you just multiply this with 1000 in order to convert that into kilogram per meter cube. And your answer would be 1466 kilogram per meter cube. And in appropriate significant figures, it is 1470. Moving on to the next part, they're saying that find the absolute uncertainty in your answer in D. So, like density. So you have to find the absolute uncertainty in the density, not diameter, density. Okay, so what we do, density is mass over volume. Density is mass over pi d cubed by 6. And you know, when we have to find the uncertainty, we don't use these constant values. So it means we are left only with this. Okay, so now we will be working only upon the density equal to m over d cubed. So the formula for that is delta d over t equal delta m over m plus 3, because 3 is the power for d. 3 delta d over d. Okay, and then what you do is you simply shift the value of density to other side here to get the absolute uncertainty in density. So now I just have to put the values for you. So putting the values, delta m, we have to see that how much is mass and its uncertainty. This was the mass and uncertainty, 0.1 and 48.7. So 0.1 over 48.7. And then for the diameter, we have calculated the absolute uncertainty for diameter is here, and the mean diameter is 3.988, so 0.07. So it is 3 into 0.07 over 3.988. Remember why I multiplied 3 over there? Answer it. Yes, because of the power rule, because d power 3. That's why. Okay, and multiplied by the answer of the density, which was 1466. So if I do a quick working for you, so adding the mass and 3.988 multiplied by density, so the answer comes out to be 80.2. So absolute uncertainty is 80 because you always write in one significant figure. Okay, moving on to the question 5, which is the last question, hopefully. The diagram shows the apparatus used to investigate the flow of water through a narrow rubber tube. Okay, yeah, they fill the funnel with the water, and then there is a rubber tube, and there is a clip. This is the stopper. You can stop or start the beaker, the water, and that will be filling into the beaker. And the lower end of the tube was closed, okay, and the volume of 120 cm cube of water was filled into that. Okay, the tube was opened and a stopwatch was used to measure the time taken for all of the water to flow into the tube in the beaker. That was repeated more times using 120 cm cube each time. The result that is shown. Okay, and none of the results are anomalous. Great. So this is the time. What they do is they fill this funnel with 120 centimeter cube of water every time, and then they time it, like this clip was closed, and then they use a stopwatch to measure the time that 120 cm cube takes to completely shift into the beaker, and they repeat it 5 times, and here are the data. Okay, calculate the mean value. Okay, never mind, the mean value is quite simple. The sum of the over number of readings. This is mean. So what you do is, with the help of the calculator, you add all of them together. And here is the magic. I'm done with this. You have to guess that how I've done that. Okay, so this is 41.92 seconds, as there are 4 significant figures in the data, so I have to write in 4 as well. Next is you have to find the absolute uncertainty. So the absolute uncertainty in the mean value of t is, the maximum t minus minimum t over 2. So you just have to look for the data and you have to see which one is maximum and which one is minimum. So if I quickly look, this is your maximum value and this is your minimum value. So 43.72 minus the minimum value is 40.89 over 2. So that will give you the value of uncertainty in your mean as 1.415. So this is 1.4. You can write 1.4 or 1.42. That is fine. So just 2 possible causes of uncertainty in T. Okay, this is a big uncertainty, 1.42 second. So the first reason is, well, because every time they have to replace the volume of 120, so we can say that every time volume of water may not be 120 cm cube. It can be more than that, it can be less than that. That's why they take different time. And secondly, error in time due to starting or stopping the watch at wrong instant. The human reaction error. We say this can be human reaction error. Human reaction error, right? Okay. Oh, there's one more part left. I thought that was the last part. So now the average rate of flow R is volume per unit time. So volume is this, so you have to find R. So the volume is 120 and the mean time, T is of course the mean time that we have calculated is 41.92. So you divide it with 41.92. So 120 divided by 41.92. So you get the average rate of 2.8625. So it is 2.86 meter cube per second. And then the measuring cylinder has a resolution of this. It means this is the absolute uncertainty. estimate the percentage uncertainty in your answer of R. So R is actually V over T. So it means percentage uncertainty in R is equal to percentage uncertainty in V plus percentage uncertainty in T. And one more thing is this is delta V over V into 100 plus this is delta T over T into 100. So what you do is you just put the value over there. So the delta V is 2, as they have told you, and the V is 120, you already know, multiplied by 100, plus for time, the uncertainty in time comes out to be 1.42. So you're writing 1.42, and the average time was 41.92 multiplied by 100. So that sums up your answer. So 2 over 120 into 100 plus 1.42 over 41.92 into 100. And that gives you the answer of 5.05. So it means just 5.1 because your answer was 5.05. So we can write 5.1%. State what is meant by precision of the set of the measurement. So precision means closeness of measured values to each other. Okay, students, well, we are finally done with that. So what you will do is you will be writing, you'll be scoring yourself, and then you will tell in the comments that how much is the total score of yours. I would love to hear your score. Thank you so much. We'll see you in the next video.